We've been working on the shore of Denman Island, and we're setting up a new experimental site near Eagle Rock. We're looking at comparing 6 different restoration techniques. The idea is there's different ways to replant kelp into habitat where it used to grow and it doesn't anymore. So we're interested in just seeing how the techniques perform relative to one another. We chose Eagle Rock because it was one of the last places that kelp grew in this area before it disappeared completely. We think that there might be some slightly different oceanographic conditions there with a bit of more current and cooler water. And so that we thought that it would be a good place to try to replant kelp. We went out and just sort of delineated the site. We marked the general shape of the place that we were going to set up the experiment. And we also did a background biodiversity survey. So we went and looked at what organisms are already existing there before we reintroduced kelp. And then we started building a little underwater fence. So this is a new technique that we're working on to keep sea urchins from eating our experiments. There's definitely a lot of urchins around here, especially places where kelp used to be. We're looking at trying to restore kelp, replant this ocean plant where it used to grow. And one of the things that can limit that is grazers, herbivores, and sea urchins are a really big factor in that. They like eating kelp at its various life stages. After we finished the fence, then we relocated the urchins. The thing we did is we placed 30 1-meter plot markers, and they will hold the different treatments that we're going to apply at the site. So we have 6 different experimental treatments, and we need 5 replicates of each. The reason for that is so that we can really verifiably say if something works better than something else. If it happens once, it's a sort of a coincidence. If it happens a couple times, maybe also a coincidence, but if it's 5 times, then that's considered to be statistically significant. We're comparing kelp babies that are grown on a tile substrate. We have some kelp babies grown on string. So the string will be attached to the rock so that the little plants can grow onto the natural bottom. We're also looking at kelp babies that are grown on various sizes of small rocks. So this technique is known as green gravel. And we're comparing quite small ones and some medium-sized ones and larger ones just to see which are preferable. We're also looking at direct seeding kelp gametophytes, which is a new technique. So that will be basically sort of baby kelps in sticky goo that we're going to apply directly to the rocks. So our restoration approach, it's sort of multi-layered. So if these treatments grow well this year, then we've created some kelp forest habitat, which is amazing. And it's always interesting to see the animals start using it right away. So that's sort of like a very short-term benefit. If any of our kelp were to recruit and grow to the next generation, back in this site, then we've accomplished sort of reseeding it, at least in the medium term. And the other thing we're looking at in the medium term is the Kelp Rescue Initiative has plans to expand the amount of restoration they're doing in terms of the size of the area and the number of locations. So we just really need to have some good information about what works and what doesn't before we try to scale up our efforts.